Solubility. So solubility relates to having a solvent, normally water, into which we dissolve things. And those dissolved things are called solute. Now to show you a very common experience of this, I can take some water and dissolve sugar in it and get sugary water. The sugar is the solute and the water is the solvent. Now if you carry that topic on, the solubility topic, then the values of solubility as to how much dissolves are to do with having a certain quantity of water. And if you watch my videos, that's the quantity there. 100 centimetre cubes. Just put it that way. Look. There's a 100 centimetre cube beaker. You see the markings? 100 ml beaker. So the industry standard is to see how much solute you can dissolve in 100. Now if I fill that beaker up, that is 100. And how much sugar can we dissolve in that? Well, that is about a small cupful. And when I was at university, I had a friend who, when we made tea, he wanted 5 teaspoons of sugar in his tea. And I thought that was ridiculous. Sometimes I would put 4 in, and sometimes I would put 6 in to see if he would know the difference. And he did. He knew the difference between them. And I find the whole thing pretty amazing. But it inspired me to think, if I've got 100 grams of water, how much sugar will dissolve? So if I put that, because I need space to stir, if I put that in a bigger beaker, a 250 ml beaker, and if I get a glass rod for stirring, let me just get the whole of the beaker in. Is that all of the beaker? I'm hoping that's all of the beaker in. Maybe if I there. Okay, so if I get 1 spoon of sugar, I've got sugar here, sucrose. I'm going to put that into a beaker, just so that I can get a spoonful of sugar into my beaker. Now, when we're trying to dissolve things, if you can see, and they dissolve, that dissolving necessarily means the particles in the solid separate. And when they do, we won't see any solid in the beaker anymore. See those grains of sugar floating around? Then when the sugar dissolves, we shouldn't see any of that. And there should be none on the bottom. There's still quite a lot at the bottom. So it's taking time to dissolve. And I haven't got that much time just to wait for it all to dissolve each time. So I'm going to speed things along by heating it, but I want you to see. Perhaps if I lift it up. I want you to see the important thing I'm trying to teach you is if the solution is transparent, then there are no solid bits in the way to stop the light. And that's how we know something's dissolved. The solution is transparent. Now watch again. If there are solid bits, that's 2 spoons of sugar. If there are solid bits, look, they stop the passage of light. And you can see that then it's murky, then it's opaque. then the light doesn't go through. So I could stir that up again for a few minutes and get that sugar to dissolve. I know 2 sugars will definitely dissolve. And just to speed things along, I've got a Bunsen burner, and I'm going to, if you see the apparatus set up, I'm going to just start heating. I'm going to start heating the sugar using a Bunsen burner. Now, when we heat, what we're doing is we're giving energy to the water, and the water particles moving faster, they will bump into the sugar harder, and they will break the sugar up into particles. And what happens is, then what we see is the dissolving is faster. Now, just give me a minute to lift this off. There's some condensation around the sides, which I just want to get that clear. You see that? The sugar has dissolved. That is transparent. So that's 2 sugars. Well, how many sugars will dissolve? Let's try my friend's 5 sugars. 2, 3, 4, 5 sugars. Let's see if 5 sugars will dissolve in that 100 centimetre cubes of water that I started with. I know it might seem a bit tedious, but really what I want you to look at is the appearance inside where I'm stirring inside the beaker. Can you see it? It looks opaque. Opaque means you can't see through it. You can't see through it, there's solid in the way. It's not dissolved. Can you see that? It's dissolving, but it's not dissolved. When it's dissolved, it will be transparent. And that's the main thing that I'm trying to teach with this demonstration. Now, if I stop stirring, because stirring introduces air into the mixture, and sometimes it's the air bubbles that will stop the passage of light. Now, I've made this makeshift beaker holder, and I can lift this using that, like that. Can you see? You see through it. If you can see through it like you can, then we know 5 spoonfuls of sugar have dissolved. So how many more should I put in? Let's go for 6, 7, 8, 9, 10, 11, 12. That's 12 spoonfuls. You can see there's a whole load of sugar at the bottom there. If I stir it and get it moving around the beaker, then the beaker looks as though it's got little pieces of sugar floating around. They block the light and it's not all dissolved. I know when it's all dissolved, when I'll be able to see through it and there'll be nothing left at the bottom, which will take a bit of time. The Bunsen burner will be warming up the water to make this happen faster than it would do otherwise. Speed it along. But then I have to stop stirring to see if it's dissolved. And there, if I stop stirring, and then the air bubbles I've introduced, the air bubbles might leave. You see, the air bubbles are leaving, and the mixture is clearing. And if you look at the bottom of the beaker, there's no sugar. The final few particles of sugar have dissolved, and there, that's all dissolved. So that is a sugar solution. And what was that? Was that 12? 12 spoonfuls of sugar have dissolved in that small amount of water. Now, let's try and go berserk. Let's get more sugar and go for 13, 14, 15, 16, 17, 18, 19, 20. 20 spoonfuls of sugar. And let's see if 20 spoonfuls of sugar dissolve. Now this is going to take a little bit of time. In that time I want you to know that solids dissolve better and quicker if you warm them up. That's why I've got a Bunsen burner underneath the beaker. But gases are different. With gases, they dissolve better the colder the solvent is. So fundamentally there's a difference between solids, where we want the solvent to be hotter to get better dissolving, and gases, where we want the solvent to be colder to get more of the gas to dissolve. That's why fizzy drinks, when they're cold, retain more of the fizziness. When they're warm, they lose the fizziness. Well, what did I get up to? 20. 20 spoonfuls of sugar. Do they dissolve? Well, now I leave it. There's some bubbling going on there. That bubbling is boiling. So the sugar solution is starting to boil. Okay, so that's about the hottest I can get it. But I don't want you to see the bubbles. It's not a boiling experiment. If I take the Bunsen burner away, look, I've taken it away. Then the bubbles stop because the boiling stops. And if I let the tiny air bubbles leave, then that will become clear, transparent, telling me dissolving has happened. So 20 spoonfuls of sugar have dissolved. Can you see the volume as well? The volume, we started with 100 mils, 100 centimetres cubes of water. There's a volume in there, that's probably got a volume of about 200 centimetre cubes. The volume has gone bigger and bigger as you've been adding more and more of the sugar. So rather than bore you with carrying this on, let's try a big beaker. Here I've got a 1 litre beaker. No, actually it's an 800 centimetre cube beaker, 800 millilitre beaker, and I'm going to take this sugar solution and pour it in to my much bigger beaker. Now I'm going to put the Bunsen burner underneath again, and I'm going to go for 40 spoonfuls. So that was 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40. 40 spoonfuls of sugar in that 100 ml of water, and I've got my glass rod, and I've got a Bunsen burner underneath it, and I can stir, and I can try and get it all to dissolve. And the reason I put 40 in is I think I won't be able to get 40 to dissolve. I think with 40 it will stay opaque. Look, you can't see through that. That is not clear. That is not transparent. Now we need, of course, we can get the sugar hotter, the sugar solution hotter and hotter, and then you might think, oh yeah, it will dissolve. But we can't get it hotter than its boiling point. So when it starts to boil, then I'm hoping to see some sugar floating around even when it's boiling. And if there's some sugar floating around, even while it's boiling, can you see the crystals of sugar? I can see crystals of sugar, and there's some sugar floating around the bottom as well. Can you see the sugar floating around there? The sugar floats around, and that shows you that it hasn't dissolved, because you can see it. Now when a solution dissolves and it's hot and there's quite a lot dissolved, then when you cool it down, the solubility of the solid is less, and as you cool it down, the extra solid that was dissolved, that can no longer now stay dissolved, comes out as crystals. The process of cooling down a solution and getting crystals is known as, believe it or not, it's known as crystallization. So, some important ideas about what you look for to check whether something is dissolved. And you look to see if you can see through the test tube or the beaker or whatever it is. If you can see through it, dissolved. If you can't see through it, not dissolved. And if you cool a hot solution down and crystals start forming, then that's called crystallization. And crystallization is all to do with what quantity, at what temperature will dissolve. At a hot temperature, it will dissolve X amount of solid. At a colder temperature, it will dissolve less than X. And the difference may come out as crystals. And these kind of calculations are commonplace within chemistry calculations. Okay, I'll leave it there.